In the previous lessons, we learned about molarity, and molarity is represented by the letter M, capitalized M. And every time we see this capitalized M, we have to realize it is a conversion factor of number of mole A divided by 1 liter of solution. So always, okay? So in this case, we are going to look at another type of problem with molarity, where we are going to learn how to prepare a solution. Well, to prepare a solution of 5.5 liter solution of 0.80 molarity of NaCl, sodium chloride. So again, this right here can be represented by L, so, okay, it's in liter, okay, that's a key thing. This is liter. Now, when we see this right here, it is 0.080, that is mole of NaCl divided by exactly 1 liter of solution, okay? So that is a conversion factor for molarity. A student would need to weigh how many grams of solid sodium chloride. So to solve this problem, we always go back to these ideas, starting with our given. Remember, we never start with a conversion factor, so this is our given. We want to make that solution at that specific volume. So we have 5.50 liter of solution. There you go. And multiply by our next conversion factor that has liter of solution, which is this one right here. So in this case, the liter of solution on the bottom. And the top part must be 0.80 moles of NaCl, or sodium chloride. Now we want this to be in grams, so we have mole, liter solution cancels out, but now this is mole, we want it to be in grams, and now we have this conversion factor, which is your molar mass right here, okay? This is your molar mass from your periodic table, your PT right there. If you don't know how to find it, use a periodic table. Now we multiply. See, this is mole of NaCl, so this part, moles of NaCl will be on the bottom to cancel out 1 moles of NaCl, that cancel out. If moles NaCl is on the bottom, this part must be on top. 58.44 grams of NaCl. Exactly what we are looking for right here, right? Grams of NaCl. Now all we have to do is take our calculator, multiply everything on top, divide everything on the bottom. And since it's all 1, we can ignore it. And our answer is 257.14 grams of sodium chloride. So to prepare this solution with a volume of 5.50 liter, with a concentration of 0.80 molarity, we would need to add 257.14 grams of NaCl in a 5.5 liter of water. And that's how we would make this solution at that specific concentration. Let's try another problem, but in this problem, we're going to make it a little more tricky. In this case, what we have here is to prepare a 650 milliliter solution. Notice this is milliliter, so we need to convert to liter. And again, because this is milliliter, we need to convert to liter of solution because molarity is in liter of solution. But we have the conversion factor right there, okay? And I'm going to show you how to use it. And the same thing, the concentration is 0.85 molarity of potassium chloride. So the concentration is this one right here. And again, express this as a conversion factor. And as a conversion factor is 0.85 moles of KCl divided by 1 liter solution. Just the way we have right there, right? We need our volume to be in liter. So let's continue the problem. A student would need to weigh how many grams of solid potassium chloride. The same thing, we are looking for grams, okay? So let's look at this problem. First of all, we have our milliliter. This is your given. And of course, we're going to write it down. It doesn't matter if it's not liter. We're going to convert to liter right now. So we have 650.00 milliliter of solution, okay? time, well, we need to find a conversion factor that convert milliliter to liter, which is right here. So this milliliter is on top, so right here must be the milliliter, 1,000 milliliter of solution. And the other side must be 1 liter of solution. And notice how milliliter cancel out. And that is how you convert into liter. Easy, isn't it? Now we're going to multiply to the next conversion factor that has liter solution, which is from our molarity right there. So we time that. In this case, because this is liter, the liter of the molarity has to be on the bottom. So we have 1 liter of solution. On top would be the mole, which is 0.85 mole of KCl. Look what happened to the liter. It cancels out. Now we have mole. We now can convert it to gram, which is right here, moles and grams. See, moles and gram. So we multiply by that, okay? So in this case, what we have here is the mole going to be in the bottom. So mole of KCl, which is right here. If mole is on the bottom, the other part must be on the top. So we have 74.55 grams of KCl. Look what happened to the mole. It cancels out. And all we have to do is now is multiply everything on top, divide everything on the bottom using a calculator. 650 multiplied by 1, multiplied by 0.85, multiplied by 74.55, divided by, on the bottom, 1,000, divided by 1, which we can ignore, and divide by 1, which we can ignore. So now what do we have? We have 41.188. That would be 41.19 grams. So our answer is 41.19 grams of KCl. This solid potassium chloride will be added to 650.0 milliliter of H2O. And that's how you make this solution at that specific volume with that specific concentration. Let's try another problem that deals with milliliter. In this case, to prepare 120 milliliter solution. So again, this is in milliliter, ml sol. So we need to convert this to liter of solution, okay, using this conversion factor right here. And we have a concentration of 0.30 molarity. And that can be expressed as a conversion factor, 0.30 moles of Na2O divided by 1 liter of solution, okay, sodium oxide. So a student would need to weigh how many grams of solid sodium oxide. The same thing, we start from a given. We have 120 milliliter of solution. And we need to convert that to liter of solution using this conversion factor here. See how this is milliliters, so the milliliter go on the bottom. 1,000 milliliter of solution. On top would be 1 liter of solution. Milliliter cancel out. Now we have liter of solution. We need to convert that to mole, which is using our molarity. And we are going to multiply that. We have the liter going on the bottom, so 1 liter of solution, which is right here. And on top would be 0.30 moles of Na2O, sodium oxide. See how this liter cancels out, right? And now we have mole. Guess what we need to do next? We have to use this to convert to gram, which is exactly what we're looking for. So the mole would be on the bottom to cancel out. So we have 1 mole of Na2O, which is sodium oxide. On top would be 61.98 grams of Na2O. And now all we have to do is multiply everything on top and divide everything on the bottom using a calculator. So we have 120 times 0.30 times 61.98 and divide everything on the bottom, which in this case we only have 1,000. And that turned out to be 2.231, which is, so we need 2.23 grams of sodium oxide added to the volume of water, in this case 120 milliliters of H2O. And that's how we would make that solution. So that's how you prepare a solution of specific concentration for a specific volume by measuring a specific amount of solute.